Bismillahirrahmanirrahim. It's Ali Hussain, and let's quickly. The topic of the presentation today is about malware analysis and tools. It's more specific to some technical guys and the audience from the academia and maybe the IT professionals who are the network administrator who used to know more about how the samples behave, and this is more about some technical things I will like to elaborate. And if you have any questions, you can ask. You can stop me anytime. So I will be just doing the overview of this, and let's start it from. Okay, this is the outline. I won't go into details of this. We'll cover it, and let's straight move to the first point. So, why do we need malware analysis? Because in every organization, there are big firewalls out there to protect the systems, automated IDS systems. So, but those are not enough because software cannot do all the things for you. So, there has to be a man effort to further assess the risk and to analyze the incidents. So here comes and there is another aspect why we need malware analysis is because the threats are very short in the duration. There is a specific category called zero-day attacks. The prime purpose of those are just to breach the system and to maybe to defame the organizations or just steal the data. So those attacks have very short spans. So the automated system cannot cover it and process it in short duration of time. So the manual efforts and some custom effort has to be made to cover all those security loopholes. So the certs are the specific organizations across across the world. So there are regional certs, there are local country certs. So they look after the incidents. They take the samples and they track records of all the previous breaches and how they come into growth. So it can be email, it can be suspicious emails, it can be some file types, or it can be some bot family which propagates via some pen drive or something like that. So this is why we need a specific skill set. We cannot rely on the software itself only. So in that malware analysis, so the first and the foremost important is the network traffic analysis, and in that there are a couple of tools to analyze the network traffic. But as from the point of view of a network administrator, what you will receive is alerts from your IPS IDS system. So it is some rules which triggers, and then it also generates some PCAP for you, and then your boss assign you what this incident does, how it does, and this is we're going to talk about how we can like extract information out of that PCAP, so that we can understand what it do and how it does. So the Wireshark, the most popular, you all know, and you can self pick the traffic as well. And if you want to simulate some page or some samples, so you can also generate this traffic in the virtual machines. So this is we're gonna cover example here. Quick example is, so you work as a security analyst for a company with location worldwide, and it's recently opened a field in the Japan. So but you got an alert in your IDS system that there is some breach in the Japan office, and you got a PCAP. So what you want, your organization bosses want is want you to analyze that PCAP and know what's the MAC address, IP address of the host name infected, and what's the date time in the okay. So first point, the MAC and IP address of the infected PC. How you gonna find out? Okay, a quick piece. You have to start with the OSI model. So when that computer connects the internet, what does needs? It needs DHCP protocol to resolve. So in your PK, what's the port number of the DHCP? It's 67. So in your PCAP, if you just filter, there is some I think this thing UDP port equal to 67, you will find out all the DHCP requests here. So in this simple scenario, there was only one DHCP request from the IP, this IP. So you want to know this is the guy who tried to visit some websites, and then it lands in some malicious websites, and it got hacked or somehow. So this is and in the header you got a lot of information about the host name, username, IP ports, and data. So you can extract information by connecting dots like this. So you can find the dates and time when it was when the first time it start browsing, and what time it stops, and what websites it visits in what duration of time. So second is the daytime the computer was infected, so can easily be tracked because this is the IP, and if you filter, if you apply filter of IP, you can know all those traffic associated with that IP, and then you can start analyzing those HTTP requests, post requests. So and you can extract them. Interesting feature is here there are options to you can extract the streams. You can right click on and particular stream packet, and then follow TCP stream. It will show the TCP connection established in that particular stream. But if you want to export all those objects involved in these sessions like PDF or JavaScript or whatever, then you can go from a file and export objects. So you can dump all those objects embedded inside or involved in the whole HTTP session or all sessions. So then you can one by one analyze those the suspicious ones, and then you can start your investigation from there. So this is how you will start analyzing the APK, the PCAP. So this is some details about the host name, which is also available in the optional header, and similarly the MAC address and the malware families you can track down with straight away with the IDS alert as well, because IDS alerts usually contains the malware family names or the expected. So you can start kind of like knowing about what like vague description of the thing what it was. And then if you are still not sure about what this thing that URL does, there is a website called virustotal.com. This is basically an interface of more than 50 antiviruses. So you can submit as MD5 or URL over there, and you get to know you will know the feedback of around 50 antiviruses instantly after. And then you're gonna know this how the is this a new thing, is this and all those 50 antiviruses feedback you're gonna see, and this is gonna like very clue point how you're gonna start the investigation, and is this worth worrying about this domain or not. These are a couple of filters. I'm skipping it, and there are a lot of some online tools available like TCP number, etc. I'm not going to cover it, so let's move on. So software vulnerabilities and exploits. So vulnerabilities, it's just a flaw which is like when it's just a door which available in it's due to the design or the flaw in the algorithm. And then that vulnerability itself like it does not make any sense unless you manage to misuse that, and for the misuse you will for sure go for executing the malicious code. So that code is called exploit, so it's also called a shell codes. So using vulnerability you just find a door, and then you execute some code using that door. It's exploit. So vulnerabilities plus exploits are the main very like important things to analyze and to track down. And these experts, when in the security research community discover them, they publicly disclose. And there are a couple of forums which take care of all those discovered exploits. So they are called CVEs. Those CVEs database is available online, so you can search if your sample correspond to some CVE or not. And there are a lot of undiscovered and discovered exploit kits and the bots variants which also rely on these. So assume you are going to visit a website, and and on the web page in the browser it is not allowed to execute. Browser is not supposed to execute any executables, right? So if there is a exploit or the vulnerability in that particular page of the browser itself, then the malicious thing is if they manage to execute. So so if the browser is managed to execute an executable, this means this is exploit, because in the normal scenario it has to pop up some alerts, and then if the user want to execute, it can first download, and then he used to execute himself, not the browser. So using the exploit vulnerabilities, you can it's how the attack does is, when you just visit it exploit the flaw and then execute that code. That code correspond to the operating system code, so it's assembly instructions which directly got executed, and the malicious executables got executed, and if it is executed, it's his will, so your system is most probably compromised. And the most okay, and this as a security analyst, the most important thing is you have to have a good memory to recognize the patterns and the research of the previous communities or current developments in the security industry. So you have to remember the patterns involved in and the flow involved in specific malware families. So this is very important as a security analyst. You have to be used to of the tools, and at the same time you will have a good memory to keep records of, this, when just visiting the PCAP, you should be able to identify this PCAP correspond to some malware or not. So in the rest of the presentation, we'll be just getting an overview of some tools which are useful to make you confident and make you realize that is this worth going in that direction or not. So those tools I'm going to talk about briefly. This is the interface of virustotal. So you can just submit any sample, and it's gonna these are the list of antiviruses, and this is a real-time analysis basically. So it will display the feedback like this. And there are a lot of proprietary services they offer for using the REST APIs. You can integrate this in your custom applications, or in you can automate the submission and the analysis of your thousands of samples for the educational purpose or whatever. So this is very good useful industry tools, so you can use in your research and the analysis. And this is the URL of the. So this is basically a database. It's a gateway of more than 50 antiviruses. So you can use that, and you can also integrate it. These three are one of the few of the very good resource to follow. The threat experts, you can submit APK and the sample itself to know about. So this is how you extract streams from and objects from the PCAPs, and then you're gonna see if this object is a compromised or not, is gonna harm or not. So these are sort of things. So first you're gonna analyze the domains and the IPs maybe, or URIs, and then if doesn't make any clear verdict out of it, so you will go for analyzing the HTTP stream whole, and you will extract the objects, and you will submit and try to see if there is any publicly available details on in these forums. So there are in analyzing the objects, there are two ways: the static and the dynamic ways. In the static ways, this is binary static analysis, very useful tool, which is the PE Studio. So it gonna emulate not emulate, it's gonna just map the structure of the executable, and it extracts all the, and then it's compare it with the legitimate executable formats, and it's gonna indicate whether it is whether there are some indicators. You see here the virustotal feedback, it can also fetch those stubs, so this can be small patches which the executable itself can drop and execute, and this all those here interesting thing is the certificates. Is this a file valid certificate or not, the strings. So this is gonna static analysis of the sample. So let's give a very quick overview of what this executable does without executing it at all. And then here is another one which also try to unpack it as well. So most of the time the complex sample is encoded or packed, so you're gonna unpack it first. So this is a very good profiling tools. So in order to know the object more, and it's the data structures involved, because it's all about it's a executable, or whether it's a PDF or whether it's a PPT. It's just a file format and specific data structure. So this is a 010 editor which is used to map those your own object with the standard file format, and you're gonna see what field correspond to what value, what offset has what value. Like you open it in a hex editor, you're gonna see 10101010. So this tool is gonna tell you like these set of strings correspond to what data value. Like here you see this is a data structure. So when you load it and apply a filter, you're gonna see these 2 bytes correspond to what value. So this is very useful in knowing knowing the file structure itself. It's very easy to use because you don't need to worry about this. This is all you need to copy the file structures, and you're gonna just apply the template, and it's easy to use. Then there's another one which is if you want because malware in the real life it just evolves. You just run it can delete itself, or it can like do operation and then remove its artifacts and all the mutex registry. So in real-time analysis you can use the volatility. You can just set up a virtual machine. You can execute the sample and then create a dump of it. Then in that dump, because the dump contains the RAM artifacts as well, so you can use the volatility to analyze that dump, because it is doing network activity. It's gonna make connection, then disconnect. So after when you are using some real-time tools, so it's gonna maybe not log that activity. So you if you want a real-time activity, you can use this. And some of the useful tools like they give very quick and very brief like idea about what it does and how it does. It's a string, hex term. There is a lot of GitHub. If you visit GitHub, there's a lot of contribution in this direction in the GitHub, so you can find a good firmware, and mostly the Python language is used as a scripting. So if you are good at the Python, there are a couple of tools you can use. And then in the IDS, these are the 2 things mostly used: the Yara rules and the snort rules are used to write the signatures which are deployed in the firewall and are used. In the dynamic analysis part, because the ever evolving this domain, it has very it's every day changing. So it's not like one executable. Sometimes it's like interdependent samples which works together. So the infection vectors are also very diverse. So it's not like it's just one executable. It may be that it is the part of some set of 10. It has 10 parts maybe. So one part you have, if you're gonna have 2-3 more parts, then it's gonna execute. So it's better to have a dynamic or emulation based analysis of the samples. So this is a very good open source tool which is used to emulate your own sample. So what you're going to do is this firmware you install, and then it is compatible with the most popular VMware virtual machines, the QEMU, etc. So you're going to create a snapshot of the QEMU virtual machine, and then connect with this. So this is gonna sit in a separate machine, and there is an agent of this is gonna reside in that virtual machine. Then you're going to execute that sample inside, and it is logging all the activity offshore in the second machine. So if you there is also interface of publicly deployed interface as well, but you can, for educational purpose or the research purpose, you can have your own copy in your own research lab, so you can analyze. Its power is it logs very like all the activity of the sample. It reports like network activity, file systems activity, and all those mutex and the what it does. It got reported in an independent file. But the only limitation you see here is because the sample usually detects the emulation environment or the debugging systems. So if this is the case, then this tool you have to tweak it, or maybe you have to do something, develop some plugin itself that can detect that, because this is open source, and if you are good at some programming stuff, you can always develop the extensions and the plugins for this. But this is very good, and it gives a very comprehensive report as well, which also include the static analysis report of the VT and all those stuffs. So this is a very good point to start. This is a list of its publicly deployed version, and it is it has around this much publicly analyzed samples, so anyone can use that. These are some of the APIs which it hooks. So in the user mode hooks, it works, and it reports using that hooking APIs. So these are some of the suspicious APIs which hooks. And then you can always have a custom version of the virtual machine and analyze a sample in that. But one thing I want to quote is, you can, if you want to go for your custom machines, there is a chances you can discover the unknown vulnerabilities as well by tweaking the versions, or and then changing it to newer versions. So most probably the newer version is the one going to be targeted by the unknown malware family. So by visiting the log and combining it and then analyzing it carefully, maybe you will be able to discover the unknown vulnerabilities exploit. You can publish it on your own name. And some of the other dynamic analysis tools. So Microsoft has a good list of sysinternals tools which can help in debugging and knowing more about the TCP connections, or some of the drivers, the sample loads, the handles used by that particular sample, debug logs, and all that. This is another tool which you can, it's the real-time analysis tool. So you can run a sample and apply a filter here, so it's gonna capture all those samples activity, and you can have a good overview of what it does in the real time. That's another one which also working the same way, but it has a different specific reason. It can assess any process, not just one process. So you can assign and attach and detach any process in the real time. So this is the biggest challenge in the malware analysis, because the sample can detect the analysis engines and the software itself, and it can be a dependent sample. It can be a dependent or highly targeted sample which works only in a particular set of softwares, or in the particular it is highly targeted to work for specific organization or some specific network. So you have to dissect the sample in order to know why it is not working. If it is able to produce some useful evidence, it is good enough. Otherwise you have to disassemble it, you have to reverse engineer it to know more about it, why it's not gonna produce anything at all. So these are the common some of the common techniques used. The process following, like it can be like it's not the Windows based technique. So in the process following, this one process did not execute some code itself, but it execute in another thread, which is in another process. In fact, so this is a legitimate feature in the Windows, but it's gonna misused by these malwares in today to execute a code which in another process. So if you're gonna analyze the sample itself, you can't see the malicious activity because the code is being run in another process. So another is the DBG presence. Using that you can detect the presence of the debugger if the sample is loaded in the ID Pro or DBG or whatever. So and this is a check. This is another API. And interesting, this is a find window. It's just Windows API which just extract the name title of the software which is being run right now. So if you are using loading a sample in some debugger, so it's also gonna check that if it is the title is the known like the tool as well. So if it is the tool, so it gonna quit or not produce the enough activity. So these are some of the evasion techniques. And now in the final part of presentation, I want to because a lot there are many IT administrators and network administrators here. So this tool is very like good for scanning the whole network. So let's say we have 100 devices in a network, so we want to know what devices are vulnerable, or if there is if there is a network devices or the end user device is vulnerable for any vulnerability and exploit. So Nexpose is a Metasploit tool. So if you want to run in your network, it will map it will perform its test, and then it will apply all the known CVEs, and then give you a report that if the particular CVE can exploit your system or not. So this is going to give a good results about your network traffic network, that if my network is vulnerable or not. So you can then one by one visit the reported vulnerabilities and can patch all those unpatched softwares to in order to protect your system proactively. And then if you are more curious about the reverse engineering and the low level stuffs to learn, so these are the very good resource. You can have a video trainings and the like PPTs, and it's very good, very useful, very deep and very clear introductory to advanced analysis with the Android analysis and forensics to descriptions of the techniques, open security trainings. And then there's another one, Sabrari IT. This is relatively new, and but this is also useful and a freely available resource on the internet you can use. And finally, I will like to have some thoughts about the roles in an organization when it comes to data breach. So normally the organization does not proactively prepare for that, and if some incident happens, there are a lot of time they spend about blaming, and then there is no SOPs or the dedicated procedures defined. What's the role of IT, what's the role of communication department, what's the role of legal advisors, what's the role of CEO. The blame is the IT guy. So it is the responsibility of the whole organization, and there has to be proper capacity development for the IT staffs, and everybody has to aware of the security loopholes, and there has to be proactive measures to patch the systems. And that's the end of presentation. Thank you. And any questions? No. Okay, thank you.